students, welcome you all to the seventh lecture on costing related to textiles. We are in the calculation of spinning cost, that is yarn spinning cost. In this lecture, we'll see on the power cost. The technical term related to power cost is UKG, units consumed to produce 1 kg of yarn. Let us look into. We can see the components of the various costs in related to yarn spinning. The major cost is the material cost. The other costs are labor cost, power cost, stores, interest, depreciation, and others. Let us look into the Citra data, recent Citra data. This is 2020 data. The raw material costs given for a few counts are given here: 30s, 40s, 40s combed compact yarn, 60s combed compact, and 100s combed. We see that the raw material cost ranges from 50 to almost 70% of the total cost. The second highest cost in a yarn is the power cost. It ranges from 10 to 20% of the total cost, as we see in this chart. So it is the second largest component in the total cost. The other costs are given here, and we can also see the net profit margin for the various counts. And you can see that in a spinning mill, the net profit margin is has low compared to the other textile industries. The profit is due to the voluminous and not per unit contribution is slightly lower compared to the other textile industries in the total supply chain. So, going to the classification of the costs in a yarn spinning mill based on variability, we see that power cost is a variable cost. When you account for the cost of the machinery, the power costs consumed by the machinery are variable. It changes according to the quantity of the yarn produced, whereas the humidification and lighting costs are going to be fixed whether you produce less or whether you produce more. So this is a classification. So you can tell that the power cost is a semi-variable cost. Partial is variable and partial is fixed cost. The power cost, as it is very high, and raw material, we already saw that it is not under our control. We can only control the waste. By reducing waste, we can improve our contribution. The next is the conversion cost. In the conversion cost, the first and foremost is our power cost, and since this is very high, it has to be effectively estimated so that we adopt proper control measures in the required place. Only if we estimate it right, we can see where to control the power cost, where it is high, to find out where the power costs are high, in which department it is high. So we have to split it first according to the departments or according to the counts, so that we can see which is more profitable based on power cost, and whether the non-productive machines, whether they are consuming more power, and what is the lighting cost, whether we can go for any changes in those things. For this, we have to divide and find the correct estimate of the various components of the power cost. So to do this, mills have placed sub switch boards in each department so that we can estimate the department powers, units consumed, so that power cost can be estimated. And when some, for a particular department, it is high compared to earlier, then we can see that there are some power losses, and proper action can be taken in that department for effective control of the power cost. This table shows the power consumption of the various departments, productive and non-productive. The first two are the productive departments. In the total productive departments consume 70% of the total cost, and in that 50% of the total costs related to power are with the ring spinning department. The load in ring spinning is very high, and all the preparatory machines consume 20% of the total power. And the third important is the humidification plant power cost, which accounts to 13.5 percentage. The autoconer department consumes 9 percentage, and next compressor, lighting, and the other costs. So the same is shown in the power in the pie chart. So that we get a better understanding of where the power costs are high. So if we compare this for various counts, we can see the variations, since the pictorial representation gives a better understanding. So the measure of power consumption and power cost for comparison are given by Citra. For power consumption, for comparison purposes between mills, between counts, UKG is used. UKG means units consumed to produce 1 kg of yarn. So the number of units consumed per kg of yarn, it is converted to 40s, so that we can make a comparison of that. And next is the power cost per kg of yarn. So these two are the terms related to power consumption and power cost. So we have what is UKG? So if we have 410 units, this picture is taken from Zitra norms. The total units for 100 kg of yarn, if it is 410, then UKG means 410 divided by 400, you get 4.1. So UKG is 4.1. If a mill is a good a mill is rated good if its UKG is less than or equal to 4, and it is rated as average if its UKG is between 4.1 and 4.3, and the mill is rated below average mill if its UKG is greater than 4.1. This rating is based on power costs. Rating based on power. So if our rating in other things are good, raw material and others, labor costs, we have to concentrate more on power costs. So we can see where we are lagging from these comparisons. So for before going into the power cost calculations, we need to understand what is power. So 1 unit, we told already UKG, units consumed per kg of yarn. So we should know what is a unit. 1 unit of electricity means 1 kilowatt hour. That is, if equipment or a machine of 100 watts load is used for 1 hour. When it is used for 1 hour and it is of 1000 watts, then it consumes 1 unit of electricity. Or and if the equipment has or machine is of 100 watts and it is used for 10 hours, then it is 1 kilowatt hour. 1 kilowatt hour is 1 unit of electricity. Just to give an understanding of what is a unit. Let us now go into a simple calculation of UKG and power cost, where all data are given here. We will see a simple problem on that. I want you to look into this problem and note down if you need to calculate the same for your better understanding. If you are students, then you need to note it down and calculate so that you will get a better understanding. So the kilowatt hour or the units consumed for the first column is what I am mentioning here. 1 kilowatt hour for 8-hour machine running hours. If a machine runs for 8 hours, what are the units consumed? So if in a chute feed system with the blow room and card, totally it consumes 125 units if it runs for 8 hours. So one card with the total setup, if it runs for 8 hours, then the units consumed or kilowatt hour is 125. Similarly, draw frame with one passage, 30 units. Draw frame second passage. I'm sorry, the first one is uh, one delivery machine. That is what I meant as passage. Here it is second draw frame, the second passage, 25 units, fly frame with 120 spindles per frame, consumes 56 units. Ring frame 1008 spindles per frame, consumes 292 units. Auto corner 60 drums per winder, consumes 160 units. So these are the productive departments missions, and the last three are the non-productive areas. Humidification plant consumes 50 units for 100 kg of yarn. This is already calculated. Compressor 26 units for 100 kg of yarn. Lighting and other consumes 6 units for 100 kg of yarn. The next column gives the production rate for 8 hours. So for we have already seen or the data given for 8-hour machine running units. Next is 8-hour production. For if the machine runs for 8 hours, what is the production? So it is for a card it is 370 kgs. First draw frame passage 780 kgs, second 820, next fly frame 4 kg per spindle, 100 gram per spindle. This is your GPS, the technical term grams per spindle, 100 grams per spindle for 8 hour when it runs for 8 hours. Next auto corner 8 kg per drum. And the next is calculated value given here. It is the production required for 100 kg of yarn. When you need 100 kg of yarn in the ring frame, that is 100 GPS and 1000 spindle machine, then you will produce 100 kg of yarn in the ring frame. Assuming no waste in the auto corner, we have given 100 for ring frame on auto corner. For 100 kg of yarn production in ring frame, what is the production required in the previous departments? That is fly frame 102, draw frame 103, and a card 115. This the data is given for a carded yarn. So next we'll look into the calculations for the same. And before going into the calculations, we need to know the formula that is to be used for calculation. So the units consumed for 100 kg of yarn, UKG, in various departments, various productive departments, the formula is given. In jute feed, the units consumed for 100 kg of yarn production is units consumed in the jute for 8 hours into production quantity required for 100 kg of yarn production divided by production rate, that is production for 8 hours per machine. If it is draw frame, then it is based on the number of delivery. If it is a 2 delivery machine, then you in the divisor you have to multiply the number of deliveries, and if it is fly frame into the number of spindles, and if it is ring frame also in the denominator number of spindles, and units consumed in the auto corner, in the divisor you have the number of drums. For calculation of the total units consumed for 100 kg of yarn, we have to sum all the units consumed in all the machines productive, and then along with that add the units consumed by the various non-productive departments. This is the way uh, we need to calculate for UKG calculation. The same is shown here in the Excel sheet. One thing you have to note, the first passage has 2 deliveries, and the second passage it is, if nothing is given, then we have to take it as 1 delivery. Here in this area, the first draw frame passage has 2 deliveries, and the second passage, when nothing is given, then you have to take it as 1 delivery. For the other things, it is the same. Now let us go into the calculations. First, we need to calculate the number of deliveries or things. We have to note this here so that it will be easy for calculation. This is already a given data, not calculated. So in the shoot feed for with the blow room and card, the number of deliveries one. It is per card. It is only one delivery. For the draw frame, as I already said, it is two deliveries, and second passage one delivery. So there are 120 spindles in fly frame, 1008 spindles in ring frame, and 60 drums for the auto corner. So this is one given data, not calculated. We have to put it here so that we do not miss in the calculations uh, uh, for exact calculations. So now let us calculate the UKG. UKG is nothing but the number of units consumed for production of 100 kg yarn. So for that, it is we already saw the formula, so we know it already. So I'm showing the data here. It is for the first one, it is 125, which is the units consumed into production requirement divided by the production rate. 125 into 115 divided by 370. So we get the units consumed to be 38.85 for the card and the blow room totally for 100 kg of yarn production. Next, first passage, similarly 30 into 103 divided by 780 into 2. So 1.98. Next, draw second passage of draw frame. It is 25 into 103 divided by 820 into number of delivery is 1. So 1. So we get 3.14. Fly frame 56 into 102 divided by 4 into 120. So 11.91 units. Ring frame, similarly, we have 2292 into 100 divided by zero point 0.1. Since it is in grams, we have to convert into kgs for for correct calculations, divided by 1008. So we get the UKG in here in ring frame this much. We can see that the power cost is high in the ring frame, as we already saw in the tabulation percentage of total power. So the auto corner, it is 160 into 100 divided by 8 into 60. Next, these three data are already given: humidification, compressor, and lighting. So the units were already given directly for 100 kg of yarn production. So we can write the same. So now we can calculate the total productive blue color and non-productive. Total units consumed for all productive and non-productive departments. Sum of these things, we get 460.89 units. And next is the UKG. So 460.89 divided by 100, we get the UKG. So units consumed per kg. The above is for 100 kg. Total units consumed for 100 kgs. So we divide that. So we get 4.61 by rounding off. Then we have one more given data, the power cost per unit. So the power cost per unit is given as 5.5. I think it is 6.5 now, but for calculation purpose we are using 5.5. So the total power cost is total units into power cost per unit 2534. It is 460.89 into 5.5, and the power cost per kg of yarn produced is, you can multiply UKG into power cost, or total power cost divided by 100, because the production is 100 kgs. So it is 25.35. 2534.89 divided by 100, you get to 25.35. And it is also the same for UKG into power cost. Also, you will get the same value. You can cross check here. So with this we have calculated the UKG and power cost per kg of yarn produced. So these are the things which we have to calculate for comparison purposes where we stand. So 4.61 is a very higher UKG as per Citra. So it is a below average mill based on UKG. Thank you.